What can you guys tell me about density? Before I just jump right in. What is density? Mass over volume. Now, we talked last week about intensive versus extensive properties, so it's a good time to review that with our quiz coming up. What's the difference between an intensive property and an extensive property? Sam? Yeah, so the way you kind of think about it is extensive is kind of like on the outside. Now, take it a little bit further. That's not the full idea there, but it's kind of the way that helps you distinguish between those. Extensive meaning kind of like outside, meaning what? What else does that mean? It matters how much you have. Like it's external, sort of say, of how much you have. So extensive means that it depends on how much you have. Where intensive then doesn't, right? It's inside. It's kind of within the substance. It doesn't matter how much you have. It's part of its identity. Is density intensive or extensive? Does it matter how much you have of a substance? Does it ever change the density? No, so it's intensive. So like you guys said, mass over volume. Archimedes was kind of the first guy to kind of discover this. He was this old Greek dude who was tasked by the king or the emperor, whatever you call it, of Greece, to figure out if this goldsmith, actually he wanted this crown of pure gold, but he thought that the goldsmith forged it. All right, like it wasn't pure gold. So he tasked Archimedes. Now think about a crown, right? Can you easily get the volume of a crown? No, because it's very intricate. It's not just length times width times height. So he was tasked to come up with the volume. He knew the mass would be fine. He'd be able to get the density of the gold crown. And if it matched up with the density of gold, it'd be great. He would know it. If it didn't, obviously it was a fake. So he was the one who kind of came up with water displacement, which I believe you guys know something about from a previous lab. Yes? Water displacement. Oh, okay. Look at that. So he was the guy. He shouted eureka when he realized it because he got in his bath and he realized, oh, the water level changed when you got in there, so he could use that to calculate the volume. So density, mass over volume. You guys, I'm sure, have heard of the density triangle before. Yes? All right. So if you ever forget that, pretty easy. I believe, though, in your reference packets, density is one of the formulas that's given to you. If you look at the very back table, yep, first one right there, so you don't have to memorize it. You have to know how to apply it, which, again, should be pretty easy for you. So, example number 1 says, what is the density of concrete that has a mass of 8.76 grams and a volume of 3.07 centimeters cubed? Okay, pretty straightforward. I always encourage my students throughout the year, write down your variables. This is a pretty straightforward problem. You guys know what formula you're going to use, but later on, for your Regents exam, you're going to have tons of different formulas that we've looked at. You've got to identify which one it is. Density is what we're looking for. V equals 3.07 centimeters cubed. Mass equals, bless you, 7.6 grams. Piece of cake. Do the math with correct sig figs. From here on out, guys, you should be rounding your final answers to correct significant figures. So, with that being said, first off, what mathematical operation am I doing? Division. So that means I report my answer to what? The least number of sig figs, right? Don't look at just the decimals, it's the sig figs. Well, each one of these numbers has how many? 3. So my final answer should be reported to 3. What's that answer going to be? 2 point what? All right, should be a piece of cake, right? Easy. No problems with that. Okay. Now, what about example number 2? So, what are we missing here in example number 2? We're looking for volume. We're given mass. Grams of lead. What are we missing, though? Yeah, density. Now, I point this one out, guys, because it's not given to us in the problem. How do we figure out the density of an element? Where do we look? Yeah, table S. If you didn't figure it out already, guys, with your lab from yesterday where you have to identify the unknown metal in the lab from yesterday based on the density you calculate, Table S is your best friend. And I want to point out, everybody should flip to Table S in your reference packets right now. So you know where to look, and you see where it is, because on your Regents exam or on your quiz on Thursday, if I'm missing one piece that I don't give you, and it happens to be density, you know where to look. You have all that information on Table S. You have atomic numbers, symbols, names, first ionization we will talk about, electronegativity we'll talk about, melting and boiling points. Oh, look, there's density. All right, so what's the density of lead when you look it up? 11.3. What are the units there? Grams per what? Centimeters cubed. Thank you. Now, centimeters cubed also means what? What's another unit that equals centimeters cubed? You guys proved in a lab last week, or we're supposed to prove. 1 centimeter cubed equals something else. What? And you weren't even here for that lab, were you? 1 milliliter, right? They mean the same thing, so they're interchangeable. Now, solve for V. D equals M over V. This is where that density triangle might come in handy. You got to clear that fraction. When we move it around, guys, V should equal M divided by D. Plug and chug at that point. How many sig figs will our final answer be reported to? Which is it? I hear 2 or 3.
3 because there's a decimal.
Yeah, there's a decimal in that 25. Okay, so there's 3 sig figs in this number right here, and there's 3 sig figs in our density, so our volume then is going to be what? Pretty small. 2 point what? 2.21, and our unit's going to be centimeters cubed. What's different about example number 3, guys? We're looking for density. We're given a mass. Oh boy, what's that mass? How's that mass written? Scientific notation. Yeah. So that, we can either convert it to standard notation, or if we're going to plug something in, guys, with scientific notation into our calculator, how do we plug that in? What button do we have to use? Got to use that E button. All right? Now, are we given a volume? No. But can we get the volume? Yeah, because we're given a length times the width times the height. We can calculate it based on those linear measurements. What's our volume going to be? How many sig figs should our volume be reported to? 3. Now, what I encourage you guys to do, notice how we have to do a math problem in here to get a piece, to get one of our variables. Do not round your volume to correct sig figs. Don't worry about it. Keep as many digits as you can originally. Your final answer at the end of the problem, once we get our density, that's when you want to round. If you round this, what's the number we get when you multiply those 3 linear measurements together? Somebody just speak up loudly. I see you mouthing it. A few of you guys mouthing it. Speak up. 373,646. Okay. Notice, guys, if we were to round this to 3 sig figs, we would call it about 374,000. But that's way off, right? So our final density would be off if we rounded to correct sig figs here. So the problem is, when you're doing a problem like this, you want to keep it accurate, then wait until the very end to round to give the most accurate density possible. All right? Wait until the end of the problem to round. So now it's just mass over volume. 6.25 times 10 to the 5th grams divided by 373,646.35 centimeters cubed. Do the math. Okay? My hope is that this is a review for you. It's nothing brand new. You've seen this in other classes, guys. It's just applying it maybe in a new light. Questions?